Hi guys, it's Mrs. Warner. I can't be in class today because I have to stay home with my kiddos who don't have anybody here for them since they haven't gone back to school yet in Boston. Killing me, folks. They go back on Friday, thank goodness. So I have to be out of class today, so I'm going to have to teach this using this fabulous video that I've made. I know you're excited. Okay, so here's what we've got. We're going to divide some radicals. Please try to contain your excitement. Okay, so let's look at the first one. You want to find your note packet, first of all, in case you haven't guessed. So you want to either find your note packet or you can pull up Cami and annotate your notes online if you want. So it's division of radicals. It's our last thing in our note packet. And it says to divide radical 6/8. That's crazy. There's a fraction there. So the first thing it says is to simplify the fraction if possible. Okay, let's check this out. So we have radical 6/8. Well, there's got to be something that divides into both 6 and 8. And sure enough, it's 2. So now this becomes radical 3/4. Ooh, that's kind of fun. Because the second step says rewrite the fraction using the quotient property. The quotient property says if you have a fraction underneath a radical, you can break that apart into two separate radicals in fraction form. So like on top would be radical 3, and then on the bottom would be radical 4. So you're just simplifying and basically breaking that radical apart into two parts. Now it says to simplify it. Well, square root of 3 does not simplify, but the square root of 4 simplifies. That's awesome because the square root of 4 is just simply 2. The radical pops right off the top of that because the square root of 4 is 2. And then the square root of 3 stays square root of 3. Now, as long as there's no radical in the bottom of a fraction, there's no fraction under a square root, and the square roots have no perfect square factors, that means you have completely simplified the problem, and we have hit the jackpot on this one because this is all done. That was so fun. Let's do some more. Oh, that's really tiny. Yeah, can I blow that up? I wonder. Let's see. I'm zooming it. Okay, so we have square root of 45 divided by the square root of 15. Well, you know what? I'm going to first look to see if I can simplify that. And I know that they divide by 5, but even bigger than that, they both divide by 15. So 15 goes into 45, and 15 goes into 15 once, and it goes into 45 3 times. So this is like radical 3 over radical 1. Because 15 divided into 45 3 times. Now, there is no square root of 3. We learned that last problem. And there is a square root of 1. It's 1. And if it's a fraction and there's a 1 on the bottom, I can really just write that as radical 3. So that whole problem is just radical 3. Yay! Let's look at the next one. Whoa, somebody put a 3 out front. I did. So now I'm going to take that 3 that's out front, and there's no radical on the bottom. Do you see that? It's 3 radical 2 over 6. The 6 is not underneath the square root. That means I can actually take the 3 and the 6 and reduce them because 3 and 6 have a common factor of 2. So now this is really radical 2 over 2. Should I take that 2 and divide it into that radical 2? No, because radical 2 is naughty. He's underneath that jail symbol, the radical, so we don't want to do that. We're going to leave him right in jail. Radical 2 over 2 is my answer. Oh, same thing on this one. Look how nice this is. You've got 22 radical 56 and then 121 radical 4. Okay, people. I'm going to first try to simplify these coefficients. And sure enough, 22 and 121 divide by 11. So if I divide 22 by 11, now there's just a 2 there. And if I divide 121 by 11, It's 11. Now, does 4 go into 56? It does. But even crazier, there is a square root of 4. I could put a 2 down there. But like, since these are radicals, I'm going to first think, does radical 4 divide into 56? And it does. It goes in 14 times. Now, that got rid of the radical on the bottom, and radical 14 does not simplify. So fantastic, folks. 2 radical 14 over 11 is my answer. Okay, just like we always have, at the bottom, we have 4 practice questions. You're going to complete those in your Google Classroom in the Go Formative that is listed there, Division of Radicals practice for you. And you submit your answers in there, you show your work on this paper, and hopefully you get them correct. I set the Go Formative so that you could answer it more than once. And I think it'll give you a little green light at the top if you have it correct. All right, happy mathing, dividing radicals, and I'll see you guys again on Friday. Yay! I'll see you on Friday. I'll be there. Bye, guys.